It is great to join you today with the use of technology. Of course, I'd much rather be there in person. My name is Ron Zimmer, and as President and CEO of CABA, the Continental Automated Buildings Association, it is my pleasure to share with you today, conference delegates, some of the research and information on high performance and intelligent buildings. Now, some of you may be familiar with CABA, which is a not-for-profit industry association dedicated to the advancement of intelligent home and building technologies. The organization is supported by an international membership exceeding 320 organizations involved in the design, manufacture, installation, and retailing of products related to home and building automation. Public organizations like utilities, educational institutions, and government organizations are all members of CABA. CABA gathers research on connected homes and intelligent buildings, and in fact has well over 550 major research documents within the CABA Research Library. In this presentation today, I will share with you some of the research that has been gathered from many sources, including research that CABA has completed, such as the convergence of green and intelligent buildings, our intelligent buildings market sizing for North America study, and the recently completed Intelligent Buildings Roadmap 2011. While much of the research that will be shared has a North American slant, many of the recommendations and conclusions will be of great value to anyone involved in intelligent buildings anywhere in the world, including the Middle East. Well, how big is the market? Research that was gleaned recently from the Research and Markets Group indicates that the market for global intelligent building automation technologies is expected to increase from $130.5 billion in 2009 to over $167 billion by 2015, registering a CAGR of 4.34% during this time period. The main forces driving the market are the ability of the intelligent buildings to reduce CO2 emissions, reduce maintenance and operating costs, and enhance the life of the building and improving the safety and security of its occupants. Intelligent building technologies are segmented based on systems, services, and information technology. And systems and services are further classified as facility management systems and services, life security systems and services, and physical security systems and services. Information technology is classified into computing hardware, computing software, and computing and network services, and finally network equipments. Amongst all the technologies discussed, energy management technologies are registering a high growth rate, followed by emergency response and light management technologies. The increasing concern for global warming and increasing energy consumption by buildings are the major factors due to which intelligent buildings are gaining traction worldwide. North America led the global intelligent building automation technologies market with a share of close to 40% in 2010. But this was followed closely by Europe, Middle East, and Africa region, which had a share of more than 34% in the global intelligent building automation technologies market in that same time period. CABA's Intelligent and Integrated Buildings Council, through various collaborative industry discussions, commissioned the latest research project, which I mentioned earlier, the Intelligent Buildings Roadmap 2011, with the objective that it could assist in building industry's knowledge base and provide perspectives on intelligent and integrated buildings. Well, Frost & Sullivan, a major research firm, was commissioned by CABA, and a project steering committee was instituted for the specific purpose of funding and overseeing this collaborative research. We put in place a number of key objectives for this research project. and they were to strengthen the existing industry knowledge base and the perspectives for intelligent buildings. We were to try to understand the influence of the current and emerging trends on smart technologies and solutions, as well as the market preference and acceptance and the commercialization roadmap. We were finally to investigate the current and future direction of the intelligent buildings market and the opportunities it represents for participants of this value chain. Well, some people ask, what is the definition of an intelligent building? Well, following Frost & Sullivan's previous project with CABA, the convergence of green and intelligent buildings, the following definition was adopted to define an intelligent building. And this definition is a building that uses technology and process to create a facility that is safe, healthy, and comfortable, and enables productivity and well-being for its occupants. An intelligent building provides timely integrated systems information for its owners so that they may make intelligent decisions regarding its operation and maintenance. An intelligent building has an implicit logic that effectively evolves with changing user requirements and technology, ensuring continued and improved intelligent operation, maintenance, and optimization. It exhibits key attributes of environmental sustainability to benefit present and future generations. Also, you may wish to access the Convergence of Green and Intelligent Buildings report, which is free on the CABA website. All you need to go to is www.caba.org/bright-green. In fact, there are a number of case studies in this research report, including 2 from the Middle East, which were provided and feature Cisco Systems and CommScope. Well, what can we expect from an intelligent building? Well, we can expect improved interdependency between building systems and the building users. We can expect a building that can detect the state it is in and make adjustments to itself. And we can expect that a building that provides a healthier and more comfortable environment. And we certainly should expect some improved long-term economic performance for the building. We should see a building that reduces energy and water usage, reduces the construction and demolition waste, a building that brings higher resale value and lease rates, a building that leverages renewable energy technologies while providing improved indoor air quality and occupant satisfaction. A building that is easier to maintain and built to last. And finally, a building with advanced and enhanced capabilities to deal with churn where the occupant turnover is reduced. Intelligent buildings transcend integration to achieve interaction in which the previously independent systems work collectively to optimize the building's performance and constantly create an environment that is most conducive to the occupant's goals. Additionally, fully interoperable systems in intelligent buildings tend to perform better, cost less to maintain, and leave a smaller environmental footprint than individual utilities and communication systems. Each building is unique in its mission and operational objectives, and therefore must balance short and long-term needs accordingly. Intelligent buildings serve as a dynamic environment that responds to occupants' changing needs and lifestyles. As technology advances and as information and communication expectations become more sophisticated, networking solutions both converge and automate the technologies to improve responsiveness, efficiency, and performance. To achieve this, intelligent buildings converge data, voice, and video with security, heating, ventilation, air conditioning, lighting, and other electronic controls in a single IP network platform that facilitates user management, space utilization, energy conservation, comfort, and finally systems improvement. The main focus of CABA's research in this project was to focus on energy in the context of an intelligent building. From this standpoint, the project takes a deeper dive into understanding the developments around energy efficiency in intelligent buildings, energy performance enhancements owing to the incorporation of intelligence, and most importantly, a building's ability to interact with the smart grid. While this research advocates the traditional scope of intelligent building projects researched in the past, it makes a distinct departure from merely investigating adoption and acceptance rates of intelligent building solutions to the larger issue of buildings' ability to use, store, and generate energy. This focus is aligned with key industry trends that are now emerging in the intelligent building space, wherein the need for buildings to become net positive energy assets is heavily emphasized through policy directives and think tank-led initiatives, as well as technology innovations that are working towards this net positive energy goal. Well, we want to provide you today with a summary of the key findings of this research. An intelligent building is capable of providing its owner and occupants a flexible, adaptive, comfortable, and secure environment. This is accomplished through the incorporation of integrated building systems, communications, and controls. A building automation system is at the core of an intelligent building by virtue of its ability to regulate and manage the key functional units, from sensors to software, into a single control system to achieve seamless flow of data and control actions. Intelligence embedded in systems are capable of enhancing operation performance and resulting significant savings in energy use, resource use, and operational and maintenance costs. Energy savings, effective reductions achieved in resource consumption, as well as greenhouse gas emissions through the use of intelligent building systems, directly contribute towards making a building environmentally sustainable. This attribute has been instrumental in helping building owners understand the business case behind investing in intelligent systems, and for technology vendors to achieve commercial acceptance of their products and solutions. Initiatives and mandates from the respective departments of energy and environment in both the US and Canada, and for that matter, many other countries of the world, are increasingly being directed at reducing energy consumption in buildings. With commercial buildings accounting for nearly 40% of the total energy use, there is a serious need for this sector to reduce its energy consumption. This requires rigorous energy retrofit and digital intelligence activity to make buildings more efficient. The intelligent building product and technology vendors are consolidating capabilities to make intelligence more accessible to end users. However, the adoption rate of such solutions is inadequate, and the perception changes are needed to create acceptance. We'd like to give you a few more findings from the research. The idea of leveraging intelligence to enhance building performance, either for energy efficiency or operational efficiency, has been acknowledged throughout the research findings. By enhancing connectivity between building systems and users, intelligent products and technologies have been shown to balance operational objectives and the economic performance of buildings. Consequently, building owners and managers are now beginning to accept the multifold financial benefits of intelligent building technologies, including lower energy costs, lower maintenance costs, and lower repair and replacement costs. All of these factors are providing the cost justifications to warrant end users making investments in the installation of intelligent and integrated building systems. While there are a few challenges concerning high capital costs and low awareness, and even the sluggish economic conditions in the construction market, intelligent technologies are projected to grow steadily as a result of their importance to the energy savings and the desire to make buildings more operationally efficient. The intelligent building concept entails advanced system integration to provide a common platform that supports real-time control systems, enterprise applications, and information flow. The increasing demand for managing the entire building as an integrated system in order to achieve a more efficient facility is creating demand for more sophisticated solutions. And open standards such as SPACnet and Lawn Talk and KNX are being used over IP networks to facilitate enterprise network platforms with real-time information on building systems and operations. However, the current progression towards integration and intelligent buildings also brings various challenges. Not only do end users need to be better educated about the potential benefits, but there is also a need to transform the way the industry is segmented into isolated channels, such as electrical, mechanical, energy infrastructure, and information technology, which makes the concept of integration rather complex at the present time. As a result, system integration, technology convergence, and industry consolidation will play a key role in the evolution of intelligent buildings. The research identifies the convergence of interrelated markets, technology, and competition expected to shape the intelligent building marketplace and roadmap as part of a 2020 vision. There are companies and technology suppliers delivering the various components and technologies and services to make the buildings more intelligent from concept to operation. And the role of system integrators and installers is crucial, as they hold the key to the system's success by creating the best mix and match, suiting individual applications and with considerations made to all disciplines. The research has identified that developments taking place on the technology front and also analyzes their implications for intelligent buildings. And the following are some of the key observations that were made on the evolving trends with integrated buildings. The first is the setup for building integrated and automation systems will have a mixture of various protocols, with IP enabling an effective medium to interface with a plethora of components and protocols, and most importantly, communicating the data to a central control interface. From a technology perspective, the involvement of open protocols and IP-based enterprise systems is currently the biggest trend in the building automation industry. The second finding was that the overall adoption of wireless sensor technology is still slow. There are many challenges yet to be overcome despite the benefits offered by wireless technology. Adoption of wireless sensor technology is expected to increase through increased end-user awareness and demonstrating the ability of this technology in real-world application. The third major finding is that the immediate need is for manufacturers and vendors to support a variety of protocols. The industry is not about choosing one protocol or standard over another, but about cost-effectively integrating a multitude of protocols potentially even using middleware, to achieve interoperability and optimum energy efficiency. There is a need for professionals who can properly design and install integrated building automation system projects. The fourth finding is that as technology advances and as information and communication expectations become more sophisticated, network solutions both converge and automate the technologies to improve responsiveness, efficiency, and performance. Advanced decision-making algorithms are finding numerous applications in buildings. However, their presence is minimal. As the building industry begins to aim at higher degrees of intelligence, the presence of advanced decision-making algorithms should increase. Well, we also took a very close look at intelligent buildings and the smart grid. The continued development of an end-to-end communications layer is responsible for taking the utility grid to the next level. Although applications such as demand response are perhaps the most visible component right now, it is primarily manual in nature today. A key prerequisite for intelligent buildings to connect to the smart grid is the ability to link demand response, DR, in a building to the utility's price and demand side management signals. However, the potential to include the installed base of buildings as DR participants is vastly being ignored or inadequately addressed at present. In most cases, utilities are not ready to facilitate automated DR signals and dynamic pricing. However, there are some cases of buildings that are currently equipped with automated processes and intelligence and are considered smart grid ready. CABA's interactions with various stakeholders, including utilities in the industry, suggest that most utilities today are reluctant to cater to DR needs of a single building in the range of approximately 1 million square feet or smaller. As utilities perceive the addressable load reduction in kilowatt hours from such a building as far less compared to the significant megawatt hours of energy that they could take advantage of from large commercial and industrial users. In most cases, though, aggregators or independent service providers are engaged or can be engaged to provide such demand response capabilities for individual smaller customers. And commercial and institutional buildings customers with a smaller real estate footprint may find the cost of engaging with ISOs prohibitive, as they feel their local utility should be able to cater to this need. Well, our research shows that we also need to understand convergence of technology and the competition. The coming together of intelligent buildings and the smart grid will bring about significant repositioning of both suppliers and solutions. There are two critical aspects that intelligent solutions would have to embrace towards this objective. Building systems, the first is the building systems and solutions with end-to-end digital automation accomplished by enabling intelligent devices to intercommunicate and control each other, sometimes known as M2M. The second, incorporating IP, intelligence and communication, information management tools to manage vast streams of high-resolution and meaningful data. For buildings to embrace ADR, enabling technologies would need to include smart devices that allow the technologies to be self-sensing, self-controlling, and self-optimizing. While existing and emerging building technologies can address all of the technology requirements for creating building intelligence, it is clear that the delivery models themselves will have to undergo a fundamental change from where they are at present. The silo approaches to solutions and business delivery will have to make way for increasingly networked and integrated delivery models. The role of the system integrators and installers is crucial in addressing these issues and challenges, and CABA expects this to remain a dominant feature over the next decade. Cross-domain partnerships and collaborations will mark the trajectory of this roadmap into the future as players from interrelated domains come together to deliver optimized solutions and services. The energy infrastructure partners, building automation providers, and IT partners are emerging as the three major groups of players characterizing this competitive convergence. However, the landscape could potentially change over the next decade as new applications and services make their way to further facilitate this convergence. Among key emerging segments of partnerships, the following appear to be particularly aggressive: the automation and controls providers, the converged network solution providers, the energy analytics providers, and the new apps and value-added service providers. Industry partners will comprise a broad spectrum of product, technology, and service segments that will work closely to deliver intelligence as well as redefine an intelligent building's relationship with the smart energy grid. The implications of these trends and a converging ecosystem of partners are enormous. CABA expects vertically defined, standalone products and application markets to increasingly become a part of a larger, horizontal set of standards for hardware, software, and communications. For intelligent building solution providers, this represents an opportunity to embrace a networked product model that could potentially cut across multiple value chain partner domains. Well, what is the collective influence of stakeholders? Well, the prospects for intelligent building solutions and their potential market acceptance depend on various stakeholders and influencers that formed a core part of the research process for the research that we did. The role of these stakeholders in creating market need and customer awareness around adoption of intelligent solutions has been enormous. However, there is a need to align common goals and leverage initiatives among various stakeholder groups for faster market adoption of intelligent solutions. Charts have been included within the research report that will provide an overview of the key stakeholder initiatives required by the year 2020 for better penetration of intelligent building solutions. So here are some of the suggested workstream partnerships. For ubiquitous change in customer perceptions and progressive market acceptance of intelligent building solutions, these stakeholders can collectively play a very dominant role among the course of the roadmap and into the future. CABA suggests a set of workstream processes that could help align the objectives and initiatives of various stakeholders for developing conceptual framework and processes as well as active technology developments. In addition to technology vendors and operational framework influencers, the financial community has a crucial role to play in advancing the market adoption of intelligent building solutions. Collaboration for technology innovation will largely depend upon financial partners willing to fund such collaborations and assume the early stage risks associated with such ventures. Partnerships with both institutionally funded agencies and promoters of other financing mechanisms such as private equity placements or venture capital financing will have to be actively explored and integrated into the stakeholder influence model. An area of focus for technology vendors, standard bodies, rating agencies, as well as utility partners is the creation of standardized criteria for measurement and verification of energy savings. The current verification processes followed do not result in any standardized range of energy saving that can be attributed to systems of similar capacity and performance features. This makes it challenging for utility-led assessments and regulatory policy-driven energy efficiency evaluations to incentivize the adoption of a specific intelligent building solution or mandate it as part of a demand response program. The ultimate goal is to work collectively towards a faster commercialization strategy for intelligent building solutions that tie in with individual goals and objectives of all stakeholders. Well, you might ask, what are the timelines for these major issues? In laying out the timelines with associated opportunities and challenges for the industry, CABA has considered various scenarios, from best case to realistic, and investigated the achievability of those goals given the present state of the industry. The major opportunity triggers between 2010 and 2015 will include energy efficiency, IP integration, and a move towards getting closer to the smart grid. Energy efficiency will continue to dominate the discussions around adopting intelligent technologies. The ability to quantify energy savings and reduce operational expenses for building owners will help keep demand upbeat for the immediate period. The key challenges lie in the industry's ability to standardize measurement criteria and demonstrate short-term paybacks with the right combination of solutions and services for end users. Between 2015 and 2020, opportunities would be triggered by other fundamental changes that could be brought about by strategic partnerships and industry convergence aspects. The delivery models and ecosystems that will dominate the industry landscape. Industry participants will have to prepare for addressing the issues around an intelligent building's integration with the smart grid, with widespread adoption of automated demand response, and get ready for a next level of end-to-end infrastructure deployment. As the timeline approaches 2020, more integrated approaches to solution delivery are likely to be adopted. The challenges will emanate from issues such as the possibility of achieving complete convergence of systems and networks, and whether or not that would be realistic or cost-effective. However, as more strategic alliances are formed and stakeholder initiatives brought together, the acceptance and awareness for intelligent solutions could increase favorably. The technical challenges around convergence and integration could potentially be overlooked as new applications and technology platforms make their way into the market that are able to deliver the next wave of intelligence with more open features and harmonized interfaces, allowing for ease of integration. So in conclusion, we'd like to leave you with these main thoughts. Because the key takeaways that CABA and our members receive from this research are, number one, there is now limited customer engagement and the lack of personalization of solutions. As well, predictive and self-sensing capability of solutions may continue to hinder the value demonstrations that are required. Number two, the industry horizon will continue to be dotted by pure play and turnkey players. Competitive advantages will, however, depend upon the scalability of solutions to accommodate emerging demand in technology integration. Number three, the IP influence will dominate the convergence in domain expertise but the practicalities of full convergence are questionable and unfortunately are not a near-term reality. Number 4, the intelligent building's relationship with energy is likely to be further stressed with the ability of an intelligent building to integrate with the smart grid. However, optimized solutions in this area are currently demonstrative and will expand. And finally, number 5, industry participants do need to collaborate in a cohesive manner to make intelligent building solutions work together. However, both conceptual frameworks and technology development initiatives need to work simultaneously towards this end. Well, it has been a pleasure for me to share CABA's research and insights on the expansion of intelligent building technologies and the buildings themselves throughout the world, especially in the Middle East where this conference is taking place. As I was not able to provide PowerPoints to augment my presentation, I have asked the organizers to show 2 great video clips that will reinforce the points that were shared in this presentation. One is from CommScope, one of our great members, and the other was produced by CABA and is on our website. As much of the material that as we could cover, this presentation for those that wish can be reread and will be placed in the CABA website along with other presentations in a section for presentations. And anyone can access it and it's absolutely free. It is my hope that next year I can attend a similar event if it is held and address delegates in person. It's been my pleasure to be a part of this conference, and please enjoy the rest of the day.